Let's begin with question number 12. So there's two questions. We choose one option, but we'll discuss both. Okay, let's move it to a whiteboard, please, and begin on it. So diagram shows a greenhouse standing on a horizontal rectangular base. The vertical semicircular ends and the curved roof are made from see the vertical semicircular end and the curved roof, means both of all the outer upper surface areas are made from polythene sheeting. So radius of semicircle is r and the length of the greenhouse cell is shown. So given that 120 meters square polythene, that means it's used for the greenhouse, the total of surface area is now it's 120. Express L in terms of R. So this is the first part we're going to do. And then we're going to calculate the volume based on that. Okay, let's begin please. So the 120 is made up of area of a circle. Area of circle, because the front and back constitute the circle. You think of it like combine it straight off. This one plus the half of the curved surface area. Okay, of a cylinder. Curved surface area of cylinder. So if you notice a cylinder, there's a curved surface area formula. And then we're only going for half of it. Imagine like this. Ta-da, like that, all the way. Please take note. Okay, so let's try to write it out nicely, please. So this will be pi r squared plus half. This is 2 pi r h, but the height is actually given as L. Okay, it's a key step there. Please take note. So we can see that simplifying this, it's just pi r squared plus pi r L equals to 120. So making L the subject of the matter, we would arrive at L equals to 120 minus pi r squared, and then whole thing divided by pi r. Please take note. Okay. And then the volume of the greenhouse. Volume of the greenhouse means it's a half cylinder. Okay, so I'm just going to write here. So volume is equals to half of volume of cylinder. So if we look at the volume of a cylinder formula, half of pi r square h. So this will be half pi r square. The h is actually L. It's going to replace it now, like that, because the h is given as the letter L. That's the meaning. So the L part becomes 120 minus pi r square, whole thing over pi r, like that. When we simplify this, please take note, 1 over 2 r, okay, pi r cut, so 120 minus pi r square. Does it look the same? So we multiply out half times this thing. Oh, this becomes 60r minus pi r times r square is r cubed, like that, and over 2. Sorry, over 2. Yep, this is exactly this term. So this is how we prove the first part. Done. QED 4 marks. Okay, let's go for the second part likewise, please. So given that R can vary means dVdr is a variable, can differentiate the thing, that's what they mean. So we can use some dVdr and all that. Find the two decimal places the value of R for which V has a stationary value. So we have to find dVdr, stationary value, we have to put the dVdr as 0. Please take note. So let's write it like this, please. So 60R, writing the proved statement earlier from here like this. So pi over 2 R cubed. Okay, so dVdr, as usual, we just differentiate respect to R. This one becomes 60 minus pi over 2. And then this is times 3. R is 3 minus 1 is 2. Oh, so the whole thing becomes 60 minus 3 pi, 3 pi r square, whole thing over 2. This is dVdr. Okay, let's say we put the dVdr equals to 0. So we can solve this by making these two equal. So 3 pi r square over 2 equals to 60. So r square will equals to 100, as I mean 60 times 2, 120, like say, then divide by pi. Please take note. Oh, so it's just 40 over pi. So when it becomes 40 over pi, we just take a square root of that plus. So we get the answer as just proper brackets, and this would give the answer correctly, which is 2 decimal places. So shift square root, shift square, square root, I keep telling shift 40 over pi. So it becomes roughly 2 decimal places, 3.57. Okay, 3.57. And then find this value of V corresponding to this stationary point and determine whether it's a maximum or a minimum. Okay, so now how do we determine that part, the V, whether it's a maximum or minimum? So the general idea is, okay, now we found the stationary value. So we need to just evaluate the second differential, then put the R value inside to see whether it's positive means it's a minimum, negative means a maximum, likewise. So the other thing is to find the value of V, we need to put in the original equation. So please understand the 2 steps there, and let's calculate it out. Okay, so with R equals to that, so we use the 2 decimal place approximation is given. So the V will equals to 60 times 3.57. 3.57 part. Substitution here. And then minus pi, this and something cube, whole thing over 2. 3.57. Okay, let's calculate it nicely, please. Let's put in the calculator. 60 times 3.57 minus shift pi multiply by 3.57 to the power of 3 divided by 2. Okay, if my calculations are correct, this should be roughly, the value of V is 142, 143, because 3 significant figures we rounded out. Let's take note. Ta-da, cm cube. So the cm, the unit wise. Oh, sorry, meter. Okay, now we need to figure out whether it's a maximum or a minimum. Now, how do we do that? So what we need to do is we need to differentiate this part further. That's the second differential, meaning that this one is dv dr, right? This part, let's put a box around it, put an arrow, so it's easy to see that we're going to do a second differential on it. Second derivative, some people say like that, correct? So just times only. So it's -3 times 2, then pi r, not just the normal, -1 over 2. So it's -3, and then pi r only. So the r value, we just substitute also. Don't even need to count, because all we need is whether it's a positive or a negative. It's obviously a negative, and the negative here would indicate a maximum. That means the value of V here, in other words, V is maximum. That means the largest volume it can take under these conditions is 143 meter cube approximately. And then it happens when the value of R is about 3.57 meters. No cube accidentally. So that's the answer. Those are the answers. Thank you.